Okay, so let's recall what's an oblique asymptote first. Oblique asymptote, maybe I'll just draw in a simple example, easier to visualize. Oblique asymptote is referring to asymptotes whereby the equations of the structure mx plus c. So you have got like a slanted line and you have an oblique asymptote. An example of the graph with the oblique asymptote could look something like this, and it will tend close to the asymptote. So definition of oblique asymptote is that at this extreme end region, extreme end could be either towards the right-hand side or the left-hand side, either infinity or minus infinity. You have got your graph tending towards mx plus c. If the graph tends to mx plus c, then we say that mx plus c is an asymptote of the equation. So why I need to recap on this is because there will be transformation graphs that takes on oblique asymptote will be slightly tougher to draw. So I wanted to show with one example. So I have initially here an fx graph that they would like us to try to form this fx minus 1 over 2 graph. Okay, we try to think through what we had from last week in terms of drawing the graphs, and you always start with trying to plan through with a flow chart first. Flow chart means we start with the fx. We think about the possible replacements. So we replace x by x over 2. You can do the minus 1 or over 2 first, but the over 2 will be better, less complication for the next step. So we get f of x over 2. Before we continue to the next one, we replace our x by x minus 1. So this will be the order of things that we will be doing. The complication for an oblique asymptote problem is that you should start thinking about what happens to the oblique asymptote as well in terms of the equation. This equation, 2x plus d, what will be the new equation on the transformation? Oblique asymptote, do a separate step because you will need to think through with the exact replacements as well. So if my first step was a replacement to x over 2, I would like to do the same here. We replace it to x over 2.